Welcome my dear students for Standard 8 Subject Science Chapter 4 Current Electricity and Magnetism Module 1. Before beginning with the lesson, let us see what are learning objectives. In this lesson, you will learn about current, electricity, electrostatic potential and potential difference. Imagine students that you enter a room and what you realize that the room is dark. What is the first thing that you all will do? Yes, you will turn on the light. Since students, our homes are light even after sunset. This is all because of electricity. So today in our science class we will study about current, electricity and magnetism in detail. Because of our scientists who had worked hard on understanding the concept of electricity, we are able to use electricity in our day-to-day life. Benjamin Franklin is given the most credit for discovery of electricity, as he was able to prove direct link between lightning and electricity by his famous kite experiment in the year 1752 AD. He flew a kite with the key attached on a string in a thunderstorm. As he pulled it to it, there is a flow of electric spark from the key to the back of his hand, and shortly after the lightning struck his kite, and that's how he discovered electricity. Now students, look at this lightning. A large current flows when lightning takes place from a cloud to the ground. Let us understand this concept in more detail. Students, observe this thunder cloud. You will see that how charges get separate. This is because of ice and water particles. They separate, and as a result negative charges fall to earth, and because of this positive electricity rises from the ground, and the two join and hit the ground, and that's how lightning occurs. Students, look at this electric light bulb, electric wires, and our day-to-day home appliances. This is all because of electricity. We are able to use such useful devices in our daily life. Electricity is at the heart of many modern technologies being used by us in our daily life. Then what is electricity? Electricity is nothing but it is a flow of electric charges. Electricity is measured in coulomb. We need to keep this important point in our mind because we have to understand that electricity is flow of electric charge, and there are only two charges, that are positive and negative. Students, now let us learn about electrification by friction. If a body, after being rubbed, attracts other bodies, then it is said to be charged with electricity by friction. The following points will help you to understand electrification by friction. When a glass rod is rubbed with silk cloth, some electrons from the glass get transferred from the glass to the silk. So the glass becomes positively charged and the silk negatively charged. Similarly, when ebonite is rubbed with the fur, electrons are transferred from the fur to the ebonite, making the ebonite negatively charged and the fur positively charged. When a body is positively charged, it means that some electrons have left the body, and when a body is negatively charged, it means that it has more electrons than protons. This was all about electrification by friction. Now let's move on to an important concept of this chapter, which is electrostatic potential. Okay students, observe these two images carefully. Students, as we know, water in the waterfall flows from a higher level to the lower level because of gravitational attraction, as you all can see in image. Similarly, when a bucket is kept at a certain height, then only the water from one bucket will flow to another bucket. Similarly, if we heat an iron rod, the heat will transfer from hot end to colder end. In this way, transfer of heat takes place. Students, the concept behind this is to explain you all that how electric charges flow in a simple circuit. This is how a simple circuit look like. You need to carefully observe this because in a simple circuit a cell is placed, whereas a positive terminal and a negative terminal plays an important role in the flow of current. Let us understand this concept in more detail. Now students carefully observe this image. You will observe that how flow of current take place from higher potential to lower potential, as there is a tendency of the positive charge to flow from a point of higher electric level to a point of lower electric level. This electric level deciding the direction of flow of electric charge is nothing but it is called as electrostatic potential. Okay students, do you know the difference between a cell and a battery? First you observe the diagram of cell and then the diagram of a battery. There's a minor difference between both of them. Let us understand the difference in detail. The difference between a cell and a battery. Let us understand. The cell is the basic single electrochemical unit which converts chemical energy to electrical energy, whereas battery refers to a stack group of cells. We can say that cell consists of a single cell, whereas battery consists of a group of cells. Look at this. These are the symbols for cell and a battery. Looking at this symbol, we can easily say that a cell has a single cell, whereas a battery consists of a group of cells. This was the difference between a cell and a battery. Now let's move on to another part. Now students, do you know the direction of flow of electrons in the circuit? The direction of the flow of electron is from the negative terminal to the positive terminal in a circuit. Now let us see how conventional current flows in a circuit. Conventional current is the movement of charges from the positive side of the battery to the negative side. But the direction of current does not affect what the current does. Let us understand the flow of electron current and the conventional current in more detail. Now students, I want you all to observe this diagram carefully. This diagram shows how electrons flow in a simple circuit. Electron flows through the circuit only when the plug key is closed, and there will be no flow of electric current in the circuit when the plug key is open, as you all can see in the diagram. The bulb glows only when the circuit is closed. Now students, carefully observe this diagram. In this diagram, the direction of flow of conventional current is shown by red arrow, whereas the flow of electron is shown with the help of a blue circle. In conventional current, the electron flows from the negative terminal to the positive terminal, whereas the current flows from the positive terminal to the negative terminal of a battery. See, electrons are negatively charged and so are attracted to the positive end of a battery and repelled by the negative end. So when the battery is hooked up to something that lets the electron flow through it, they flow from negative to positive. Whereas in conventional current, flow of current means flow of positive charge, and since like charge repels and unlike attracts, therefore the positive charge repels from positive terminal and attracted to negative terminal, and that's why current flows from positive to negative. Now let us learn about potential difference. First, we will understand the potential difference through this activity. So students, take connecting copper wires and connect the circuit as shown in figure. No current is seen to flow in the bulb. Now connect in the same circuit a 1.5 volt dry cell available in the market as shown in figure. Now it will be realized from glowing of the bulb that a current is flowing in the circuit. Electrons in the wire flow due to the potential difference between the two ends of the dry cell. These flow from the negative terminal of the cell to the positive terminal of the cell. Conventional current flows in the opposite direction and is shown in the figure by the sign of an arrow. In figure A, there is no current as there is no potential difference in the absence of any cell. Current starts flowing in the circuit as soon as the potential difference is applied. Now students, let us understand what is potential difference. The electric potential is the electrical energy that an electron possesses. As the electrons move through the circuit, they release their electrical energy to the electrical load in the circuit. Potential difference refers to the loss of electric potential between any two points as an electron moves through a circuit. Voltage is measured in volts. Standard International Unit (SI unit). The SI system, also called the metric system, is used around the world. There are 7 basic units in the SI system: the meter, the kilogram, the second, the Kelvin, the ampere, the mole, and the candela. The potential difference of voltage is always measured with the help of a voltmeter. Electrical charge flowing through a wire in 1 second can be called unit current. The SI unit or Standard International Unit of electric current is coulomb per second or ampere. It can be written as 1 ampere is equals to 1 coulomb divided by 1 second. Or we can write it as 1 capital A is equals to 1 capital C divided by 1 second. Now let us quickly summarize what we have learned. We have learned about electric charges. I want you all to quickly read the important points. And the major important point is that the like charges repel and unlike charges attract each other. We have also learned about electron flow and conventional current flow. And we need to keep in mind that electron flows from negative terminal of the battery to the positive, whereas the conventional current flows from positive terminal to the negative terminal of a circuit. And we have also learned about electrical charge flowing through a wire in 1 second can be called unit current, and the standard international unit of electric current is coulomb or ampere, which can be rewritten as 1 coulomb divided by 1 second. Electric current is a scalar quantity. And we have also learned about difference between a cell and a battery. A cell is a unit of positive and negative electrodes. A cell is a device which converts the energy of chemical into electric. And battery is a combination of two or more cells. And it is used in car, ups, emergency lights. This is a symbol for a cell. And this is a symbol for a battery. Students, you all are supposed to solve these questions. Can you guess this symbol? Here's an interesting assignment for you all. You need to find out the devices in which this type of batteries are used. Thank you, my dear students.